Math is cool. No. Iterated math is cool. No. Iterated map is cool. In fact, one particular iterated map is cool because it not only uses numbers, but spelling too. An iterated map is a function that starts somewhere and tells you where to go next. So if you start at xt, the iterated map could send you to xt minus 20, or really anywhere in the number line. Let's talk about one particular iterated map, which is the number of letters in the spelling of xt. So if xt is 5, then the number of letters in 5 is 4, so xt plus 1 is 4. Let's do it again. The number of letters in 4 is also 4, and this is called a fixed point. 4 maps to itself. The number 4 turns out to be special for this iterated map because every number eventually goes to 4, or in technical language, is a globally stable attracting fixed point. Let's show some more examples. This time we'll start with a larger number, like 77. The number of letters in 77 is 12. The number of letters in 12 is 6. The number of letters in 6 is 3. The number of letters in 3 is 5. The number of letters in 5 is 4. And of course 4 goes to itself. Let's try a few more. Let's start with 24 this time. The number of letters in 24 is 10. The number of letters in 10 is 3. The number of letters in 3 is 5. The number of letters in 5 is 4. Try 681. The number of letters in 681 is 19. The number of letters in 19 is 8. The number of letters in 8 is 5. The number of letters in 5 is 4. And 4 goes to itself. But strangely enough, it works every time. Eventually it always lands on 4, though it might take multiple iterations. So we have a theorem which says this formally. The theorem says the spelling iterated map is a global attracting fixed point at 4. This means that no matter where we start, if we iterate for a while, we will always land on 4 and stay there. How do we prove this? Step 1 is to notice that if xt is above 4, it will map to a positive value below itself. So anytime you're above 4, you will either get close to 4 or go below 4. Let's show you this for numbers close to 4 just below 10. 5 goes to 4, 6 goes to 3, 7 goes to 5, 8 goes to 5, 9 goes to 4, 10 goes to 3, and if xt is negative, it maps to a positive number. This is because a count of letters is always positive. It doesn't matter how you count a negative sign, whether you call it a negative sign is one number or you spell out the word negative, which is 8 letters. Either way, you get something positive. By the way, all the decimals also map to positive numbers too. If you spell out 1.5, for instance, no matter how you spell it, you always get a positive number. So we've handled everything above 4 and everything below 0. And all the decimals too. What's left? As it turns out, everything between 0 and 4 maps to 4 eventually. 4 maps to itself, 3 maps to 5 which maps to 4, 2 maps to 3 which maps to 5 which maps to 4, and 1 also maps to 3 which maps to 5 which maps to 4, and 0 maps to 4 directly. So everything maps to 4 which maps to itself. Let's go back to the statement of the theorem. Global means covers all the numbers, attracting means everything is attracted to 4, and fixed point means map to itself. And that is why iterated math is cool.